you can try to match, try to perform the image matching, and to find out where is the best match on your image. So that's what you can do. But of course, you need to consider a little bit of the orientation, the rotation differences. So it's not like as simple as this. It's not as simple as that. But however, the idea is like that. So prediction is to give you by using the initial EOP to find the possible region that contains the GCP, and which is the dashed line over here. And after that, you will perform the image matching to find the precise location of the GCP. And after you have that, then you have everything you need to perform the space resection. That's the case. Okay, so any question over here? Any question? Okay, if no question, then let me ask you one, which is, like I said, GCP database, when you are going to maintain it, it's very costly, and the distribution of the GCP may not good enough as well. So as you can imagine, because you are working on the homework, you're supposed to work on the homework, and right now, or like recently, so you should know that when you are performing like the space you are performing any transformation with the GCP, and if the GCP distribution is not good enough, then you have larger error. And in this case, the GCP, because it's maintained by human beings, and then you cannot always guarantee that the distribution is evenly distributed, and you has enough number of GCP. Because some place that you couldn't even find any GCP. For example, like the project that we have to monitor the Southeast China Sea islands, we don't have any GCP over there. So what we can do is we can only trust the director referencing. We can only trust the EOP that the satellite company gives us. Okay, so that's the only thing that we can do. So what I'm trying to say is that if that's the problem we are facing, if we don't have enough GCP and maintaining the GCP is costly, so in this case, is there any solution to, is any other data to replace the GCP? Is there any other way to replace the GCP? Replace the GCP database, basically. Is there any way to do that? We actually talk about it, but however, well, my observation is that not everyone like really understand what I'm saying. I was saying let's discuss it a little bit more. Okay. So is there any way that we can any data that we can use to replace the GCP database? Okay, Inson, what do you think? What? Digital elevation model. How to use digital elevation model? Like what? Like like also replication? How? So you are saying we directly use the DM to perform the auto replication. But however, if you are going to use the auto replication, you need to have the good EOP. Otherwise, you cannot match. You cannot the object space coordinates doesn't really match with the image space coordinates. Yeah, and now right now the problem is we need to refine the EOP. Okay. Hey, Deborah. Any thoughts? No? Okay. You?
I think in DM but it's not correct.
DM as well. Okay, Zhen-Yong, what do you think? Any thoughts? No? No? Okay, Yi-Yun. Is there any data that we can use to replace the GCP database? The purpose for the GCP database is to give us the object space coordinates. But however, in the meantime, because we want to maintain the automatic process, so the image matching is used. And so is there any data that we could use that can provide us the object space coordinates while providing us the possibility of performing image matching? Any thoughts? Okay. So it things like you have some fun.
We just asked about data.
Data? What do you mean by data?
Which is
84?
or something.
No, it's not about that. That one. Okay. Go ahead. ICP? ICP is for checkpoint. It's for checkpoint. Angie, any thoughts? No? No? 不错. Any thought? We actually kind of talked about that before. Any thought?
Can we manually set a new GCP?
Manually said, no. Right now, like I said, we want to maintain the automatic process, right? If manual work is available, then we can do everything manually, right? Lisa, any thought? RFN. RFN is derived by the EOP as well, and that EOP is originally from the sensor, and that also contains error. RFN, RPC, what I'm saying is RPC also contains error from the original EOP, the initial EOP as well. Yeah. Oh no.
To avoid using existing map.
What do you mean by that?
For example, you have a database of the existing map from the previous surveying or something, and then we use that to.
The map.
Yeah.
You are saying the map, or but however, how can map give you the automatic process?
Oh. Maybe we can find like similar feature that can easily match with the image and the map.
For example, like you have a river map,
Yeah.
and then try to find a river network,
Yeah.
and compare that. Is there any data that has the similar characteristics as map that you can use and to perform the automatic process? Right.
We're just talking about like either map or maybe existing satellite images that already correct.
Corrected?
Yeah.
Into what?
In terms of geofence referencing, they already have the X and Y
So
coordinates.
what is the name for that type of data?
What do you mean? Sorry.
Also image. It's called also image, right?
Yeah.
You
Yeah.
correct it
Yes.
into the also image, and also image has the object space coordinates, the XY
Yes.
coordinates, right? Directly, and then with the DM, with the DM.
Yeah.
So what you can have is you can have a also image that has been corrected before. And then maybe it has been corrected, and so it has the object space coordinates X and Y. And but in order to perform the orientation modeling, you still need the elevation. So you can have the DEN to have the elevation. Okay. So with the also image, you can perform the image matching. So the current procedure is more like you have one image, could be something like one image, and you have the other like also image, and you have the DEN as well. And this is the raw image. So what you can do is you can try to, of course, this also has the the initial EOP. So by using the initial EOP, then you can perform the image matching. Find the possible region that you can find the features. So you can extract some features over here. So those could be the features that you have, and then you can go back to the EN corresponding location to find out the elevation. So you have the X, Y, Z, and then you can reproject it to the raw image. You can reproject it to that. For example, this one, we can project it to some location like over here, and we can open a search window and perform the image matching, and eventually you find out, okay, so your the matched control point is over here. So you have the X and Y, X, Y, and this is X, Y, and this is Z. So you have the GCP, and you can perform the image matching. And in this case, you don't really need to maintain the core control points. You don't need to maintain that because the whole also image is your control data. It's your control data. Okay? So this is what we are doing, and this is what most of the ground receiving station and most of the satellite images, if not all. Of course, what exactly they do is something hidden, and so I'm not 100% sure. So I'm being a little bit conservative about that. So what I'm saying is, this is what most people, most satellite companies and also ground receiving stations is doing. When they receive a raw image, they will perform the image matching with the also image. And then after you find the matched points, and actually you can obtain a lot more numbers of the ground control points, and then you can perform a better transformation in this case. Yeah, that's the case. I believe we talked about this before, but hopefully through this discussion today, you understand it better. Hopefully. Any question regarding this part? No? Okay, yeah, that's pretty much about this. And currently, just for your information, currently the whole procedure after you, for example, our what I know of, when our ground receiving station received the image from satellite, and after we receive that, and the whole process like this, and to produce the also image, to produce that after you correct the orientation, and then you will perform the also relocation. The whole process from receiving, starting from receiving the image to produce, to send out the also image, it takes about 1 hour to do it. It takes about 1 hour to do it. But with the computing technology advance, well, the efficiency will increase, will be better in the future, because as you can imagine, many things can be performed in parallel. So in this case, yeah, the speed can be increased, significantly in this case. Okay. Just for your information. All right. Yeah. All right. Any question? If not, then let's move on. All right. So yeah, here automatic triangulation. So you can perform the image matching, and then you can have lots of matched points. And then in this case, you can directly like perform the registration. And yeah, that's the case. And I'm not going to dig into the detail, but however, as you can see, it indicates the high point arrow ellipsoid. So some of the points, they have a larger like ellipsoid, and some of them have a smaller one. Smaller means the accuracy over there is better, and the larger one, as you can see, most of them, the larger one, most of them are on the edge of this whole group, because as you can imagine from your homework, you can analyze that the whatever outside has a little bit more error. Okay, so that's the case. Okay, and with that, you can have your own reliable coverage. All right, that's in terms of the space resection and the space intersection like this. We talked about this already, so let me take a look at, yeah, here is one of the application. Is by directly matching two satellite images to derive the DEM, DTN by using spot. And here is the also application. Here is the bottom-up approach, and yeah, we talked about this before. And I think this figure is very familiar to you guys, so we can skip it. And here is about the image matching, the epipolar geometry. So we defined those terms before, the epipolar axis, epipolar plane, epipolar line. So hopefully you guys still remember that. Is because the main the reason to have this is to make the image matching